Hi and Assalamualaikum. My name is Fatin Amira binti Amir Hamzah and my matrix numbers is 01DKM20F2033. Today I want to present about the water consumptions and aquatic habitat alterations. First of all, I need to talk about the introduction. Power plants must be discharged or disposed of processed water someplace. Discharge location range from streams or lakes to local municipal sewer system that eventually discharge into streams or lakes. To handle the discharge, surface waters or sewer treatment system, we must be able to absorb water that has been altered by the additions of heat, acid, and salt. Larger water bodies or stream might be able to accept more of this altered water because of their size and volume, or because they have water containing solids that can buffer the added chemicals, or they might not. Their ability to do this would have to be modeled and calculated. Pollutions and pollutants discharged to surface water from power plants can result in adverse water quality effects. Next is some power plants use once-through cooling. In once-through cooling, the cooling water is drawn from the lake or the river and used to condense the steam for recycling through the plant. The water used for cooling picks up heat from the steam, and then it returns to the lake or the river at a warmer temperature. Impacts of this technology, it could include warming the lake or river near the discharge point. Potentially, it can affect temperature sensitive plants, fish, microbial activities, or chemical and physical reactions in the water. Even with the cooling towers instead of once-through cooling, discharge processed water that is warmer than ambient water temperatures can alter the local fishery compositions, aquatic macroinvertebrate communities, and aquatic plant communities. Aquatic species can take up surface water pollutants, resulting in disease and fish contaminations.
Hi and Assalamualaikum. My name is Asam Zuhairi Muhammad Qasim and my matrix number is 01DKM20F2032. Okay, today I will present about the background of water consumption and aquatic habitat alteration. The first point is thermal power plants convert heat into power in the form of electricity. The heat is generated from a diverse range of sources, including coal, natural gas, uranium, solar energy, and geothermal energy. The heat rate HR kJ per kWh of a power plant is the amount of heat input required kJ per H to produce 1 unit electricity kW. Okay, let's see the equation below. HR equal to the heat input of fuel divided by net power output. Okay, for the point number 2 is the power plant net efficiency is simply the heat content of electricity 3300 kJ per kWh divided by the heat rate kJ kWh. Okay, for the let's see the equation below. Efficiency equal to 3300 divided by HR. Okay, next point is the power plant heat rate depends on the fuel type used and the specific power plant design. All the heat put into the plant is not converted into electricity, must be dissipated somehow to the environment. Most of this heat is rejected to the environment through cooling system, which usually use water as the heat transfer medium. Thus, the smaller the heat rate, the smaller the amount of heat that needs to be rejected, and therefore the less cooling water is required per kilo hour produced. Since between 85% and 95% of the total water needs in a thermal power plant for cooling purpose, we can get a good estimate of the total water needs just by knowing the heat rate.
Hello, my name is Nazwan Gunaji and my matrix number is 01DKN20F2034. I will talk about regulation and procedures. So number one, water management plan is both types of power plants should have a comprehensive water management plan in place. This plan should include measures to minimize water consumption, promote efficient water use, and reduce impact on aquatic habitat. Number two, water consumption reduction is power plants should implement measures to reduce water consumption wherever possible. This can include optimizing cooling system, implementing closed-loop cooling system, and utilizing water-efficient technologies. Cooling tower design and operation is power plants with cooling towers should ensure that the design and operation of these towers minimize water loss through evaporation and drift. Regular maintenance and inspection should be conducted to detect and repair any leaks or malfunctions. Next, power plants should have effluent treatment systems in place to treat wastewater generated during the power generation process. This system should be designed to meet national water quality standards and should be regularly monitored and maintained. Other than that, prior to the construction or expansion of a thermal power plant, an EIA should be conducted to assess the potential impact on water resource and aquatic habitat. The EIA should identify mitigation measures to minimize this impact and ensure compliance with relevant regulations. Uh, Power plants should establish a monitoring program to assess their water consumption and the impact on aquatic habitats. Regular reporting of water uses and environmental performance should be conducted to regulatory authorities. Lastly, both steam power plants and gas turbine power plants must comply with the environmental regulation and standards set by the relevant regulatory authorities in Malaysia. These regulations may include limits on water withdrawal, discharge, and water quality parameters.
Next, I want to talk about how to prevent water resources and aquatic habitats. Firstly, we can conserving water resources, particularly in areas with limited water resources, by use of a closed cycle recirculating cooling water system or closed circuit dry cooling system if it necessary to prevent unacceptable adverse impact. Uh, cooling wat- Cooling ponds or cooling towers are the primary technologies for recirculating cooling water systems. Once through cooling water systems that it may be acceptable if compatible with the hydrology and ecology of the water source and the receiving water, and maybe the preferred or feasible alternative for certain pollution control technologies such as seawater scrubbers. Secondly is reduction of intake flow to the following levels, including an allowance for altered water requirements and water availability due to climate change. For freshwater rivers or streams, it to flow sufficiently to maintain resource use as well as biodiversity during annual mean low flow conditions. For lakes or reservoirs, intake flow must not disrupt the thermal stratifications or turnover pattern of the source water. For estuaries or tidal rivers, reduction of intake flow to 1% of the tidal excursions volume.
Hi and Assalamualaikum, my name is Assam Zuhairi Muhammad Qasim and my matrix number is 01DKN20F2032. Okay, today I will present about applicability of water consumption and aquatic habitat alteration. Water consumption and aquatic habitat alteration have significant applicability in various domains, including environmental science, conservation, urban planning, agriculture, and industrial sectors. Let's explore how these concepts are relevant in each of these areas. Okay, first one is environmental science. Water consumption refers to the withdrawal of water from natural sources such as rivers, lakes, and groundwater for human use. Understanding water consumption patterns help environmental scientists assess the sustainability of water resources and their potential impact on ecosystem. By quantifying water consumption rates and monitoring changes in water availability, scientists can develop strategies for water resource management and conservation. Number two is conservation. Aquatic habitat alteration refers to changes in the physical, chemical, or biological characteristic of aquatic ecosystem. Water consumption can lead to habitat alteration by reducing water availability or altering water quality through pollution or excessive attraction. Conservation effect, efforts focus on preserving and restoring aquatic habitat to protect biodiversity and maintain ecosystem functions. By studying the impact of water consumption on habitat, conservationists can identify key areas for intervention and implement measures to mitigate habitat alteration. Okay, for the number three is urban planning. Water consumption is a critical consideration in urban planning and development. As cities grow, the demand for water increases, placing stress on local water source. Sustainable urban planning involves assessing the water needs of a growing population, optimizing water management system, and promoting water conservation measures. By considering the impact of water consumption on aquatic habitat, urban planners can design infrastructure and policies that minimize habitat alteration and promote sustainable water use. Number four is agriculture. Agriculture is a major consumer of water worldwide. Efficient water use in agriculture is crucial for maintaining productivity while minimizing environmental impacts. Excessive water consumption in farming practice can deplete water source and affect adjacent aquatic habitat through reduced stream flow and increased pollution from agrochemical. Sustainable agriculture practice such as precision irrigation and water efficient crop extension aim to reduce water consumption while minimizing habitat alteration and water pollution. Okay, for the number five and the last one, industrial sectors. Various industrial sectors such as manufacturing, energy production, and mining require significant water resource. These industries often extract large volumes of water for cooling, processing, and other operations. Excessive water consumption by industry can deplete local water source and lead to habitat alteration, including reduced flow in rivers and increased water temperature. Implementing water conservation technologies and practice such as water recycling and efficient industrial process can help reduce water consumption by mitigate habitat alteration.
Impact in industry. The environmental issue of water consumption and aquatic habitat alteration in a thermal power plant can have significant impact on industry. This impact can be both regulatory and operational in nature. Here are some key points regarding the impact on the industry. Number one, regulatory complaints. Thermal power plants are subject to environmental regulation related to water usage and protection of aquatic habitat. These regulations aim to ensure sustainable water management practice, minimize ecological impact, and protect freshwater resources. Power plant operators must comply with water withdrawal limits, discharge standards, and regulations pertaining to the protection of aquatic life and ecosystems. Failure to comply with this regulation can result in fine, penalty, and potential shutdown. Number two, water available and cost. Thermal power plant require sustainable amount of water for cooling and steam generation. Water scarcity and competing demand for freshwater resource can be pose challenges for the industry. In regions with limited water available, power plants may face constraints in securing sufficient water supply, leading to potential operational disruption. Additionally, the cost of water evacuation, treatment, and disposal can impact the overall operation expenses of the industry. Number three, ecological impact and habitat alteration. The withdrawal of large volumes of water from river, lake, or other water body for cooling purposes can disrupt aquatic ecosystem. It may result in reduced water flow, change in temperature, altered nutrition level, and impact on aquatic organisms and their habitat. This alteration can have ecological consequences, including the loss of sensitive species, change in biodiversity, and the degradation of aquatic habitat. Power plant operators need to implement mitigation measures such as fish screen, water intake structures, and habitat restoring projects to minimize this impact. Number four, public perception and reputation. Water consumption and habitat alteration in thermal power plant can raise concern among community, environmental organization, and the public. The industry impact on freshwater resource and aquatic ecosystem can affect its reputation and social license to operate. Stakeholder engagement, transparent community, and proactive measures to minimize environmental impact are necessary to maintain public trust and address community concern. Number five, transition to water-efficient technology. The environmental challenges associated with water consumption in thermal power plants have prompted the industry to adopt water-efficient technology and practice. This transition involved the implementation of closed-loop or hybrid cooling systems, which minimize water withdrawal and reduce the impact on aquatic ecosystems. However, the adaptation of this technology may require significant capital investment and operation charge, which can impact the industry competitiveness and financial performance. Number six, water management strategy. Thermal power plants need to develop and implement effective water management strategies to optimize water use, reduce consumption, and minimize impact on aquatic habitat. This may involve water recycling and reuse, use of alternative water sources, and the adaptation of technology that enhance water efficiency. Implementation this strategy can improve the industry environmental performance, ensure long-term water availability, and help mitigate the risk associated with regulator complaint and public perception.
Assalamualaikum, my name is Safena Irani binti Sunim. I'm matrix number 01DKM20F2073. I'm going to present about community health and safety. The first one is water availability. Power plants often draw water from local sources such as rivers, lakes, and underground aquifers. Excessive water extraction can lead to water scarcity in the area, affecting the availability of water for other essentials such as drinking, agriculture, and ecosystem maintenance. The second one is water quality. Power plants that use water for cooling purposes may discharge heated water back into water bodies, potentially affecting water quality. The thermal pollution caused by warm water discharge can harm aquatic ecosystem and negatively impact fish and other aquatic organisms. The third one is environmental impact. Power plant water consumption and discharge can impact the environment beyond water resources. For instance, if water bodies are used for cooling, the intake of large volumes of water can pose risk to aquatic organisms, including fish, whose eggs and larvae can be entrained and impinged by the intake structures. The fourth one is emergency preparedness. Power plants should have robust emergency response plans in place to address potential water-related incidents, such as leaks, spill, or accidents that could lead to water consumption. To ensure community health and safety, power plants should engage in transparent communication with the local community, regulatory agency, and other stakeholders. Regular monitoring and reporting of water consumption, quality, and environmental impact are crucial for maintaining accountability and addressing any concerns promptly.
Performer indicator and monitoring method. Performer indicator and monitoring of water consumption and aquatic habitat alteration in a thermal power plant are essential for assessing and managing the environmental impact of the facility. Here are some key performer indicator and monitoring methods commonly used. Number one, water consumption. Monitoring the volume of water consumed by the thermal power plant is crucial for assessing its water use efficiency and identify opportunities for reduction. Performance indicators include tracking the total water intake from freshwater sources, such as lake or river, as well as water consumption per unit of electricity generated. Regular monitoring and recording of water intake and usage provide data for performance calculation and benchmarking against industry standards. Number two, cooling system efficiency. The cooling system used in thermal power plant is a major contributor to water consumption. Monitoring the efficiency of cooling systems so as the ratio of water consumed for cooling to the electricity generated help identify opportunity for optimization. Performance indicators like cooling water temperature difference, approach temperature, or heat rate can be monitored to assess the system efficiency and water usage effectiveness. Number three, water discharge quality. Monitoring of the water discharge from the power plant is crucial to ensure compliance with environmental regulations and protect aquatic habitats. Performance indicators include measuring parameters such as temperature, pH, dissolved oxygen, turbidity, and concentration of pollutant or chemical in the discharge water. Regulator sampling and analysis of the discharge water help assess its impact the reservoir aquatic ecosystem. Number 4. Aquatic habitat monitoring. To evaluate the impact of thermal power plant on aquatic habitat, monitoring programs can be established to assess changes in biodiversity, species composition, and ecosystem health. This may involve survey of fish population, macroinvertebrates, and other indicator species. Monitoring methods can include visual survey, sampling techniques such as seining or electrofishing, and analyzing water quality parameters that affect habitat conditions. Number 5. Environmental impact assessment. Prior to the construction or expansion of a thermal power plant, comprehensive environmental impact assessments are often conducted to evaluate potential environmental impact, including water consumption and aquatic habitat alteration. This assessment involves baseline data collection, predictive modeling, and monitoring plans to assess the potential impact and effectiveness of mitigation measures. Environmental impact assessments provide a framework for ongoing monitoring and adaptive management through the plant life cycle. Number 6. Regulator reporting. Thermal power plants are typically required to report their water consumption and environmental impact data to authorities. This includes submitting regulatory reports on water intake, usage, discharge quality, and complying with relevant regulation. The data collected through monitoring programs and performance indicators serve as the basis for this report, enabling transparency and accountability. State Number 7. Stakeholder engagement. Monitoring efforts related to water consumption and aquatic habitat alteration should also involve engagement with local community, environmental organizations, and other stakeholders. Stakeholders can provide valuable insight, observation, and concern about the planned impact on water resource and aquatic ecosystem. Engaging stakeholders help build trust, foster collaboration, and identify opportunities for further improvement.
My name is Shaira Natasha binti Idris, dormitory 01 DKM 20F2036. Environment monitoring of water consumption. Firstly, make sure that clean drinking water is easily accessible and available to everyone in the environment. Then encourage people to bring their usable water bottle and provide refill station throughout the space. Next, promote the benefit of drinking water and encourage people to drink water regularly. Then make sure the water is safe to drink by regularly testing the water quality. And lastly, keep the environment clean and tidy by providing suitable waste disposal and cleaning facilities. Occupation, health and safety of water consumption. Firstly, ensure that the water source is clean and safe to drink. Secondly, install water filter and purifier to remove any harmful impurities that may be present in the water. And then encourage employees to drink water regularly, especially during hot weather or when performing strenuous physical activities. And lastly, provide access to clean drinking water at all times, because this can be done by installing water dispenser or setting up water station.
In conclusion, water consumption is a significant factor to consider when it comes to power plant operation. Power plants require water for various purposes, including cooling, steam generation, and pollutant removal. The amount of water consumed by a power plant can vary depending on the type of plant and its specific technology. Water consumption in power plant, particularly thermal power plants, is a significant consideration due to its environmental impact and potential strain on water resources. As the demand for electricity continues to rise, it is crucial for the power generation industry to prioritize water efficiency and explore sustainable solutions to minimize water consumption and mitigate potential environmental impacts.